Greetings, the Astro 30 here yet again, and welcome back to AEL. Now, I'm looking back again at this Playmaster Pro Series 3 power amplifier, and I really hate things that I can't solve issues with, because it is kind of annoying. But I've done some further investigation and I've come to, well, a couple of conclusions. In the last video, there was a few comments left behind, thank you very much. One was to check the voltage drop across these Zeners in the biasing network here and compare it to the working channel. The voltages were roughly the same. I have replaced both the Zeners and the signal dials respectively anyway, but of course to no avail. And a lot of people would probably disagree with just throwing parts at something, but the diodes are relatively cheap and, you know, why not just replace them? They are 30 years old. Actually over 30 years old to be exact. However, I have noticed one issue which is interesting. This heatsink bracket is red hot to the touch. This amplifier module is not loaded, there is no input signal, it's just sitting idle, and it is getting very, very hot. I'm feeling these two VAS transistors, there's quite a fair bit of heat behind them. As for up here further, yeah, well, the heat's going to spread, but I can't tell those PNP transistors, which are the constant current source, sorry, the current mirror to the VAS transistors down here, are cooler than the VAS transistors themselves. They are pretty red hot to the touch right there. The other channel is also unloaded, no input signal. There's a bit of warmth in it, yes, that's only because of the bias current running through the output stage, but the bracket itself is barely warm to the touch. And the current mirror transistors are cold, and so are the VAS transistors. There's a clue. So something on this side is causing these transistors to heat up, which would give us a good idea as to why the output signal looks like absolute complete crap. Is because, well, these transistors are unable to conduct properly, I guess would be a way to describe it. And that can come from two places. Either the current mirror is not really functioning, like one of the transistors is leaky or something, as suggested by Tony Rogers to test them to make sure they're not leaky, but I'd have to pull them out of circuit to do that. But yeah, the amount of heat that's going into this with the thing idle and no input signal, non-loaded, is very alarming. So Trevor's bench also suggested I should test the voltage drop across that 100 ohm resistor, or the one on the other side, whichever, it doesn't matter. See what voltage drop we got there, so we can see how much current is being drawn by the long tail pair and the VAS circuitry, and compare it to the working module. So I'm currently in volts DC on my multimeter, and then if I measure across that 100 ohm resistor, which is the DC bypassing resistor, 1.2 volts, okay? So if I go to the other side and measure the other one, which is here, I'm not really worried about the polarity of the probes, 1.4 volt. So the working channel is drawing 14 milliamps, because 100 ohms divided by 1.4 is 0.014, so that's 14 milliamps. The other is 12 milliamps. So current being drawn by the VAS circuitry and the long tail pair seems normal. And there is a 22 kilo ohm resistor up here next to this large 5 watt 10 ohm resistor, which is coming off of the constant current source to the long tail pair. Measuring the drop across that, I got around 21.6 volts, I believe it was. The schematic says 22.3, but that equates to roughly 1 mA of current being supplied to the long tail pair, and it's the same exact voltage on the other side. Therefore both input stages are running at 1 mA. Seems fine. So now I'm at a loss as to, well, what is going on here. But I'm kind of now leaning towards we've got a faulty transistor. It has to be. Because even unloaded, I'm not getting any output voltage into the oscilloscope. I'll just restart the oscillator, because I wanted to turn it off to see if this channel would cool off cooler than the other one, and it does. So apart from the waveforms being all over the place in voltages, but see, the bottom trace is the faulty channel, top trace is the working channel, and even unloaded, the working channel is pushing 4.38 volt RMS, and the left, or faulty channel, is only producing 1.87 volt RMS. So there is, I'm going to say definitely there is an issue with the voltage amplification stage, because, well, it's the one responsible for producing the amplifier's overall gain. And for some reason, it's overheating and it can't do that. So with it in its buggered mode, I'm going to spray those heating transistors, if I can get the freeze spray to work, to cool them down, see if that makes any difference. Apparently not. Okay, so the current mirror it's not yielding us any different results here. Oh, there it goes, it's just come back up again. Well, isn't that interesting? And then it went away. So, which set of transistors was it? I reckon it's the current mirror. I'm running out of spray. Totally run out of spray now. Well, I can't seem to get it to do what it was doing before, so I'll try and get this at an angle. It's jumping all over the place, and what transistor I'm actually hitting for reference is this transistor here, which is Q7, which is actually the part of the current mirror that goes to first transistor of the VAS here. Although so yeah, considering my freeze spray is now completely empty, which is now useless to me, I'm going to have to buy some more. But I am now surmising that's possibly the current mirror, one of the current mirror transistors. What I might do is, because Q7 is connected to Q5, which I'm not sure which one it is, I think it's this top one, which is the first MJ340 of the differential VAS, which its collector is then driving our clip detect light, because the clip detect light's coming on. So that part of the current mirror is this transistor here with the base and collector junctions joined, the MJ350, is supplying current down through here to this first transistor of the VAS. There is also a 8.2k 1 watt resistor going in series with the two, bypassed with a 10 nanofarad capacitor, which is fine, but measuring the voltage drop across here, we should be seeing 53 volts. I'm not. I'm seeing 45. And on the working channel I'm seeing closer to 60. So it's wildly different on the other channel as well, but considering I'm only getting 45 volts on this channel and closer to 60 on the other, is a good indication that there's not the right amount of current flowing through this circuit. Because remember, the voltage drop across this 100 ohm resistor is only 1.2 volts, which equates to 12 mA, where the other working channel is 14 mA, so there's 2 mA difference. Not that that is bloody red hot now. So I'm going to kill the oscillator before it kills the amplifier. I'm going to say there's probably something wrong up here in the current mirror, or it could be a combination of the current mirror and the VAS. Honestly, I probably should just replace all 4 transistors. It's the only thing I've got left. I've got nothing else. Absolutely nothing. I don't know if I've actually got 2 of each of these transistors. I'd have to have a look. In fact, yes I do. I've got 3 of each. I've got 3 4.0s and 3 5.0s, which were for another project, but I've already got what I need for that. So I might spend the time, man, that was getting really hot, taking these transistors out, replacing all 4 of them, and just be done with it. Because, yeah, when I did actually spray up here with the free spray, the signal corrected itself, so there's definitely something probably wrong with the current mirror. But it could be a combination of both, is what I'm saying, so it's just probably easier just to replace all 4 at the same time. Yes, it's a bit of a bastard doing that because of how awkward it is to unsolder things on this thing. And trying to unscrew it at weird angles, and yeah. But I'll get it done, so give me a few minutes to half an hour to do that, and we'll come back with some results. If it fixes it, great. If it doesn't, well, back to square one. It does tend to help to press record, Astro. Anyway, about 40 minutes later, I've got the new VAS components in, the current mirror, the 3 5.0s, and the VAS transistors, the 3 4.0s. It is powered on. There is some warmth going into it. That's fine. But amazingly, we have an output on both channels, the same signal strength, and the waveforms are clean. Isn't that special? And if I move the amplitude around, it is working as an amplifier. Now, it's still unloaded at this point. I just wanted to verify that the thing was working. And I want to thank Tony Rogers yet again for pointing me in the right direction of what the issue might have been, because he was thinking in his head, he wasn't like 100% certain, but because the clipping light was on, and that's part of the first half of the VAS circuit, that there was something going on with that particular part of the circuit, being that part of the current mirror and that particular VAS transistor. He just happened to be right. But I found out something very interesting. Now I'm using TO220 rubber silicon isolation washers here because, well, the mica ones had become very brittle with age and were starting to disintegrate. And there was all that nasty heatsink compound on there, so I decided to get rid of it. But that's not what I found interesting. There's the old transistors there with 2 of its mica washers. Now, one totally disintegrated, so it ended up in the bin. And then when I was getting to the last MJ340 to replace it, because they'd taken the bushing part of the isolation kit, cut the head off, used the head on the underside of the PCB to isolate the nut, and they put the bush bit that they cut off over the thread of the screw. For what reason, I don't know. But the mica washer was nowhere to be found. It doesn't exist. And it probably never did in the first place. And that's this transistor here. So what that means is, someone's obviously dicked around with this module at some point in its life, taken the VAS apart, maybe to replace a transistor, because this one, which was not isolated, or had no washer, was a different brand to this one. So they were probably trying to correct a problem somewhere, broke the washer, thought bugger it, and so basically the collector was now grounded to the case, which is effectively shorting the collector and emitter junctions out. Well, there's a 100 ohm resistor across it, but yeah, that means it's, for all intents and purposes, shorted, therefore it's not going to work properly. That could have been the whole issue. And because it was covered in so much of that old heatsink compound gunk, it was really hard to see it. But there you go. So it's good to see that this is actually producing an output. I mean, that side is still getting hotter for some reason. I don't know why. Maybe the bias is too high. So I might actually turn the bias right down to there somewhere, I think. I think it might be being biased too high, so the output stage is running a little bit hot. It hasn't affected the signal where I've put the bias. See, it's still producing a relatively good signal. I can't see any crossover distortion even at this resolution. But both channels are even. So what I'm going to do is I'm going to leave this run for 5 minutes. Oh, there we go. It is actually starting to cool off now, so the bias was way too high. That's a lot better. Not sure where that bias should be set, but I'm going to leave it where it is set. Yeah, so I'm going to leave that sit 5 minutes and see if it cools right back off. If it does, then I will load it back into the load and test power output with both channels, see if everything's hunky-dory, then hook it up to some speakers, do a sound test, and this video. I'm so glad to see that I've actually repaired this. And as I've been talking, that is starting to cool down significantly. So yeah, the bias was way too high, because yeah, I rotated the pot clockwise more than I should have rotated it anti-clockwise more, but that's alright. It survived. Okay, be back in a few minutes. Yeah, it's cooled off quite acceptably now. The bias pot's almost nearly fully clockwise and just cranked about 1/8 of a turn off. Obviously, I meant when I was talking about where the bias should be set, it's rotated fully clockwise to turn the bias down and fully anti-clockwise to turn the bias up, it appears. But that's about now the same temperature as the other module. Well, no, the other module is a little bit cooler, but this hasn't really had time to cool off that much, but it seems to be effectively, you know, for all intents and purposes, perfectly fine. So now it's time to reload it. So I'm going to turn the oscillator right down before I mess around with loading each channel. So I should be able to just do that and that. That was our bugger channel, but it's still there. Grab this one and load it. Now they're both loaded. I apologise if I was in the way there, but it's really hard reaching over a camera. Stick that on 10 volts per division and we'll crank it up. Seems good. It is starting to make a rather angry hum from the transformers, but it is producing power. I've got it up to 28.2 and that's about as far as I really want to push it, which is close to 100 watts into 8 ohms, so we know it can push at least 100 watts per channel into 8 ohms. That's perfectly fine. I'm not really going to push this amplifier any more further than that due to its age. So very, very good. I'll just decrease my voltages per division, and I don't know why I'm talking like that. So we've got a reasonable signal, and both channels fill about the same heat after I did that. So that is Bonza, box of birds. Right, so now what I'm going to do is I'm going to put the screws back in the bottom of this heatsink so the bottom is attached to it. I'll unhook all this random rubbish and I'll hook in an input signal, some speakers, and we'll see what this thing sounds like. Okay, it's hooked up to some speakers, dim bulb's back in circuit just for now. Going to turn it on. No unusual noise, so I can bypass that. It's got a hiss coming out of it, so yeah, that's fine. So let's play a track. Well, that sounded alright. Let me just kill the next track, because we don't need to hear any more music. The speakers are not going to do it any justice, neither is the camera's mic. But it sounded alright, and oh, that's nice and cold. Barely warm, so they're about the same temperature, so I've got the bias around about where it should be. So that's going to do it for this video. Just a simple thing like a transistor not isolated correctly, but from what I can see, it didn't end up on the floor, I didn't break it or anything like that, it just went missing. So, I don't know, either that or whilst I was messing around maybe it did break, but because considering the shank of the bushing was still on the screw, which would have been holding the micro washer up to the transistor's body, it's doubtful that I wouldn't have seen at least it partly broken, but yeah, it wasn't even on the bracket, so I don't know where it went. Anyway, it's all fixed and I am extremely happy, so I hope you are happy that I was able to fix it. At least I've been able to fix something, which I haven't been able to do in a while. Anyway, thank you for watching. I'll see you in the next video. I'm the Astro 30, and if you enjoyed this video, please remember to go down below, like, comment and subscribe if you haven't done so already. And as always, this is the Astro 30 saying see ya, thanks for watching, have a great day.